Okay. Okay. So, as I said, we try to always use the interactive PowerPoint. So, what I'm going to ask you to do right now, so go ahead and just scan this, or if you don't want to use your cell phone, that's all right. You can go to this website, and it is a classpoint.app, and the class code is Phys120. If you are joining to the class, you don't need to put your real name, okay? Any name, okay? Because we do some activity if you don't like your name to be on the screen, so choose any name that you would like. Again, you can use your own laptop, okay? So to join to the class, you can go to the classpoint.app, and then class code is going to be physics Phys120, and you will have this access to this PowerPoint to your phone or laptop online, okay? And for the rest of the semester, okay, we will be using this, okay, class, okay. So when you log in one time, next week, when you come to the class, okay, we will use the same classroom, the class app. Okay, so please, everyone, I would like to ask everyone, if you have a laptop, just use the laptop. If you have a cell phone, use the cell phone. Okay, so because we will try to do some activity, okay, during the lecture. Okay, perfect. I will close this. Motion. So what is the motion? And what is the linear? Anything that it's moving. Okay, so we call that this particle it does have a motion. Let's say you drop a ball, okay? So what is exactly happening? It's moving toward to the ground. So we don't talk about the reason what this particle or object is moving. We will talk later. We just analyze a kinematic of the motion. So, for instance, in this physics, you will we will analyze a motion of a particle in one dimension. You may say, do we have motion in 2 dimension or 3 dimension? Yes. Okay, projectile motion, yeah? You have heard a lot about the projectile motion. It's a 3-dimensional motion. And let's say you place a ball on the table, good, and then push the ball. This is an example of, okay, if the ball not move in a straight line and change its direction to the right, left, this will be 2-dimensional motion. In this physics, we don't analyze the 2-dimensional, 3-dimensional. The only 2-dimensional motion that we analyze is going to be the projectile motion, but with the simple analysis. Good. And the other one is going to be the circular motion, because the circular motion is the example of 2-dimensional motion. Good. Because every time the direction of the ball is changing. Okay. So linear motion. We will be talking in this physics, we will be talking about a motion of any particle in one dimension, okay? And we will try to analyze the kinematic of a linear motion. Okay? So, when we talk about the motion, the first thing that comes to your mind is speed. What is the speed? Speed is distance traveled over time. The speed of a moving particle is the distance traveled over time. What does it mean? Let's say I am here and then I move to the right and then move back to the left. If I ask you to calculate my speed, what do you do? I said the distance traveled over how many seconds or minutes took I complete this motion. Okay? So we define this as a speed. The speed is the distance traveled or total distance divided by time. So, but we define an instantaneous speed. What is instantaneous speed means? When we are talking about the speed is the average speed. You may change your velocity during this motion, okay? Speeding up and slowing down, speeding up and slowing down. When we are talking about the speed, we are talking about the average speed. But we have an instantaneous speed. What does it mean? So I move again 4 meters to the right and then 4 meters to the left. You would say, okay, it took 4 seconds to complete. For instance, if it took 4 seconds to complete this motion, what was your velocity or speed at the t equal 1 or at the first 1 second? Okay? What is your velocity or speed when the time is 3 seconds? This is called instantaneous speed. So again, we have an average speed and instantaneous speed. If I want to provide an example, let's say we are calculating the class GPA. Okay, so I will ask everyone GPA, add them together and divide by the number of students. I can calculate the class average, GPA average. If I am doing the average speed, I do the same thing. I just add the velocities, okay, and divide it by the time it takes to travel. Good? But if I ask you, okay, what is your GPA average? So what is your GPA average? Because I'm asking one person GPA, okay? So this is gonna be the instantaneous GPA, okay? So we have set of data. When I just grab one student name, okay, and look at the GPA, so it's gonna be instantaneous. So I just try to explain, okay, the difference between these two. We have an average speed and, okay, instantaneous speed. Okay. So, question. You are driving with your car and you get pulled over. And the police officer, ticket you for your average speed or instantaneous speed. Okay. Probably 1 second before you were less than that, speed limit. Okay, but 1 second after, okay, you were above the speed limit. But the camera just catch you the instantaneous speed. When it's catch you, okay, then the police officer. So velocity. We talk about the speed. Speed is the total distance travel divided by total time. So again, example, I move to the right, 4 meter to the right, and then 4 meter to the left. What is my total distance travel? 4 meter, 4 meter. It's gonna be 8 meter. Let's say if I travel this, okay, in 2 seconds, 8 meter divided by 2 seconds is gonna be 4 meter per second. Yes, my speed is 4 meter per second, but velocity is different. The velocity is the displacement over time. Displacement over time. So, does anyone know what is the displacement? Yep.
It's somewhat like direction, but you to add both base, so we'll subtract. So if you walk to the left 4 meters and then walk back to the right 4 meters, then your displacement would be 0.
Perfect. So, displacement is different than the distance traveled. Displacement is, a vector. The direction is important. So, and you may say, what is the vector? Anything does have a direction and also the magnitude is called vector. Displacement is a vector. Okay? So I move 4 meter to the right, okay, and then back to 4 meter to the left. What is my displacement? If I ask you how much I was displaced in these 2 seconds, you would say, okay, nothing happened. You started from here and then you come back again here. My displacement is 0. 4 plus -4, I said that when I'm moving to the right is a positive, when I'm moving to the left is negative. How I add these two distance? 4 meter positive, 4 meter to the left, negative. 4 plus -4 is going to be 0. So my velocity, again, average velocity is 0. Okay? So again, the velocity is if I want to explain, okay. So again, the velocity is a vector, and vector does have direction and magnitude, okay? So, and when we are talking about the velocity, we assume that the velocity is vector, okay? So, and the velocity definition was displacement over time. And the displacement is a vector as well. So, you may say, what is the unit of the velocity? What is the unit of the velocity? If we say displacement is in mile and the time is in hour, the unit of the velocity will be mile per hour. And you have heard a lot. But in this physics, we use a standard unit. Okay, in the standard unit, the mile should be converted to the kilometer or meter, and the time is exactly the same time. Okay, so if you would like to just know the unit of the velocity in a standard unit, we can use a kilometer per hour or meter per second. Good. Okay, let me just talk about the vector. Okay, first. What does it mean when we say we have vector? So you all know a coordinate system. Because we are analyzing emotion in one dimension, we will be using a one-dimensional coordinate system. What is the coordinate system? If I could draw better. Okay, this is the x-axis, is a start from 0. The right side is called positive, negative. I can put a unit. Okay, let's say 1, 2, 3, 4. Okay, and then I can put -1, -2, -3, and -4. Okay, so when we are talking about the direction of a motion, it is important to analyze that motion by considering a coordinate system. Let's say I am here, okay? I assume my right side is positive, my left side is negative. But I can say that where I stand is going to be my starting point, origin. When I'm moving to the right, I'm moving in a positive direction. When I'm moving to the left, I'm moving in the negative direction. Okay? I will show the direction of the moving particle by positive or negative. Good? So if I am moving to the right, my velocity and displacement are in the positive direction. If I'm moving to the left, my velocity and displacement are in negative direction. So, and for analyzing any moving particle, it is important to, okay, let's say this person is me, okay? I am in the origin. I move to the right. 4 meter, okay, these are the unit based on meter, okay. I move at the beginning, t equals 0. I move 4 meter to the right, yes? So what is my displacement? Positive 4. If I want to calculate my velocity, how I calculate my velocity? Let's say it's take how many seconds? It take 2 seconds. Good. I move from the origin to the 4 meter to the right. Okay. If I ask you, please calculate my velocity. How I calculate the velocity? The velocity is gonna be displacement. What is the displacement? Positive. Don't forget to put the positive. Positive 4 on the top. How many seconds it takes to move this 4 meter? 2 seconds. Divided by 2, I can put meter. Second is going to be positive 2 meter per second. And I can say my average velocity when I'm moving to the right side of the coordinate system from the origin, it's going to be 2 meter per second. Positive 2 meter per second. And these positive show the direction of the motion. Another example. One more example, okay? Okay. So let's say this is a coordinate system, okay? The person is here, 0. No, sorry, the origin is here, positive 1, positive 2, okay? 3, 4, and 5. And then we have -1, -2, -3, -4. At the beginning, the person was at -4. So what does it mean? Let's say the origin was here, okay? And this is negative and this is positive. I am 4 meters behind the origin. Good? So this person is behind the origin. That's completely all right. And at the beginning, it means that I can say the initial position of this person at 0 is -4. So, and this person start moving again to the right. After, so the person cannot get tall, okay. So after, let's say, 4 seconds, let me just erase this. Good. After 4 seconds, so The final position of this person is at 4. Calculate the velocity of this person when it's moving from -4 to +4. What is how we can calculate the velocity? The velocity is gonna be displacement over time. What is the displacement here? 8, +8. So let me just show you with the color, different color. 1, 2, 3, 4, 5, 6, 7, 8. Good. 8 unit to the right. I just put positive 8 meter to the right. Okay. Divided by how many seconds? It took 4 seconds. Divided by 4 seconds. 8 divided by 4 again is going to be positive 2 meter per second. Good. Next one. Next one, I'm going to ask you to just solve the next one. This is a coordinate system. Okay, it's not a good coordinate system. Okay. So, coordinate system. Okay. The person is 1, 2, 3, 4, 5, -1, -2, -3, -4. Okay. The person is here at the beginning, t equals 0. And then after 2 seconds, the person is here, is moving to the left. Yes? After 2 seconds. Okay. What is the average velocity? Okay, go ahead and calculate the average velocity, please. 1 minute. Okay, average velocity, -2.5 meter per second. How many of you got -2.5 meter per second? You know, again, this is simple, but the conceptuality is important. Okay, because if you forget the concept of this, we may have question that try to analyze that whether you understand the concept or not. Okay, so you may forget to put negative or positive. And when we have a multiple choice, I put positive 2 meter per second, 2.5 meter per second. Some say here put negative positive 2.5, but the velocity is not positive 2.5 meter per second. Okay, so if I calculate the velocity is displacement 1, 2, 3, 4, 5. How many meter to the, sorry, how many meter? -5 meter divided by 2 is going to be -2.5 meter per second. Okay. What this negative represent? Direction of motion. Okay, what is the speed? Calculate the speed. Calculate the speed. What was the definition of the speed? The distance traveled divided by time. Okay? What is the distance traveled?
5.
Just 5. Not positive, not negative. The direction is not important. Okay? The direction is not important. It's not vector. Again, so the speed is going to be, if I just write different color, the speed will be just 5 divided by 2 is going to be 2.5. Again, the same unit. 2.5 meter per second. Sometimes you need to be careful. In the question, in the exam, they may ask you a speed or velocity. The S speed here, 2.5 meter per second, but the velocity is negative 2.5 meter per second. Okay, one more question and then we are done with the topic, okay? So we will talk about the acceleration. So, oh, one, two, three, 4, 5. Okay. So the person is at -3, okay, at t equals 0, and then move to the right, and it takes how many seconds? Let's say it is 2 seconds. Good. Okay, so I don't know why I draw a taller person. The same person, okay? Good. And then this person change his direction or her direction and move back to the same position he was. Okay, so good. Let me just draw in different coordinate system. Okay. Zero, and then it's 4, and it is -3. That's the same person, okay? Same person. It was t equal 2 seconds and another, and then move back to the where he started his position. Right now it took 4 seconds. Good. It took 4 seconds for this person to move from -3 to 4 and then come back to -3. Good. Calculate the speed, average speed, and average velocity. Okay, go ahead and calculate the average speed and average velocity. One minute. Okay. What is the average speed? How much? 3.5 meter per second. Why? How did you calculate it? You added all distance travel. Okay, so how many meter to the right? One. Okay, let me just show here. 1, 2, 3, 4, 5, 6, 7. Yep. Okay, 7 meter to the right. Let me just write here. Average speed is going to be 7 meter to the right. Okay, so plus again, sign is not important for me. When I'm calculating the average speed, I don't put the sign, positive or negative. Just 7 meter. It doesn't matter in which direction. So, and then when it's moving back, okay, again, the same 7, yes? Okay, it's gonna be the same 7. How many seconds it took for him? 2 seconds forward, 2 seconds backward. Okay, so you just write 2 plus 2, or you just say 4 seconds. Okay, 7 plus 7, 14. Divided by 4 is gonna be 3.5 meter per second. So it means that this person has 2 motion, yes? One motion to the right, one motion to the left. We add all distance traveled divided by the entire time. Good? So, but when I am calculating the average velocity, how I can calculate the average velocity? Good? How can I calculate the average velocity? Perfect. So, I am moving 7 meter to the right. Positive 7 plus I am moving 7 meter to the left. How should I write? Negative 7. Divided by, again, 2 plus 2. 7 plus minus negative 7 is going to be 7 minus 7. Yes? Okay. Plus minus is going to be negative. 7 minus 7 divided by 4 is going to be 0 meter per second. See? The average speed, okay, is 0 meter per second. Sorry, the average velocity is 0 meter per second for this person when he's traveling, okay, this 14 meter, okay, back and forth, good. But the average speed, it does have value, okay? Now we know we kind of analyze a kinematic of one-dimensional motion, conceptual, but I will give you the formula if you want to memorize with the formula. I didn't want to just say the formula first. I wanted to explain to see how we conceptually can calculate this. Now, if you still have problem with the concept, okay, you can use the formula. So what is the formula? Average speed is gonna be distance travel over time, or we call it d over t, average velocity, or we show with the v, and the speed with s is going to be displacement over time. And then I put the vector sign on the top. Good. The vector means that this is vector. Good. So, and the displacement I show with delta x over delta t, or I say x final minus x initial divided by delta t. What is the x final? Final position. What is the x initial? Okay, again, this f and I is the symbol, okay? X final shows the final position of the particle, xi shows the initial position of the particle. So, initial position. Good? So, you can just calculate whatever we calculated with those examples with the formula. For instance, if you go back here, And if you are calculating average velocity, good. What is the initial position of the person here? What is the initial position of the person? -3. Good. What is the final position? Again, -3. Yes. Start from -3 and come back to -3. So it's going to be -3. So the velocity is going to be xf minus xi divided by how many seconds? 4 seconds. -3 minus -3 is going to be negative plus 3. It's going to be 0 meter per second. But if you want to calculate the speed, I just write the speed here. The speed is going to be the distance traveled. What is the distance traveled? 14. Divided by how many seconds? 4 seconds. It's going to be 3.5 meter per second. Good. So again, you can use the formula or you can use. So memorize these two. It is important. Sorry. Okay. Sometimes we write this formula like this. xf equal xi plus v delta t. This is another form of writing the velocity formula based on position. Good. So v equal xf minus xi divided by delta t. Okay. V equal the xf minus xi divided by delta t. Sometimes you have the velocity. Good. You know the velocity of moving particle. And you would like to see what would be that person position 2 seconds later, 10 seconds later. Okay. Good. Okay. Constant or changing velocity. What does it? So if we have a motion, if we have a particle and we are analyzing its motion, and if the velocity of that particle or even its speed doesn't change, so we just say this particle move with the constant velocity. Okay. Same displacement over same amount of time. Good. Same displacement over same amount of time. Let's say you move every 1 meter in 1 second. 1 meter, 1 second, 1 meter, 1 second, 1 meter, 1 second. So what does it mean? It means that your velocity is constant. It's not changed. But if your velocity change, let's say in the first second, okay, you do 1 meter, but the next second you do 2 meters. Good. You are speeding up. Your velocity is changing. So the same displacement over same amount of time is give us the constant velocity, but different displacement at same amount of time will give us different velocity or speed. Good. Or in a simple language, if the velocity of the moving particle changing, if its displacement, okay, in per time is changing, increasing or decreasing. If the displacement over time increasing or decreasing, we will say that the velocity is changing. If it's increasing, we just say the object is speeding up. If it's decreasing, we say that the object is slowing down. So, When the velocity change, we will have a new definition. It's called, you have heard about the car is accelerating or this car is decelerating. What does it mean? Accelerating, it means that it is speeding up. Decelerating, it means that it's slowing down. Let's say you are driving, okay? You see the traffic light turning from the yellow to the red. What do? You push the brake. You are trying to slow down. You are trying to decrease the velocity of the car. So what does it mean? It means that you're decelerating. That's why we have a new definition. It's called acceleration. Acceleration. So acceleration is change of velocity over time. And the acceleration is vector as well. So it means that the acceleration can be positive and negative. When we say that the acceleration is vector, it does have magnitude and direction. It can be in the right direction or it can be in the left direction. Good? So if the velocity of moving particle doesn't change, what is the acceleration? What is the acceleration? Zero. Because it's not accelerating, okay? It's moving with a constant velocity. Good? So the acceleration of a moving particle is, but we have an example of a car or particle moving with the constant velocity, but its acceleration is not zero. Can anyone say what kind of motion which move with the constant velocity, but its acceleration is not zero? Circle. Why the acceleration is not zero? The velocity is constant. Why acceleration is not zero? Direction is changing. So if you're analyzing the acceleration of any motion, you need to analyze first its velocity and its direction. If the velocity is not changing, you cannot say the acceleration is zero. No, you need to check the direction as well. If the direction is not changing, acceleration is zero. If the direction is changing, the acceleration is not zero. We will have acceleration. In this example, when the car is moving with the constant velocity through the circular path, the velocity is constant, but its direction is changing. Because right now, when the car is here, its direction is exactly the tangent line. Yes, okay? Tangent line on. When the car is here, I could draw a car. Let's say this is a car. Good. Okay. And its direction, the direction of the motion at this point is here. Good. When the car is at this point, okay, what is the direction of the motion? Good. So we can say this is a velocity, this is the same velocity, this is the same velocity, but the same magnitude, but the direction is different. Because of the changing direction in constant velocity, we will have acceleration, and we call this acceleration centripetal acceleration. Okay? Okay. So let me just open new page. Okay. So again, acceleration is vector and its formula is the delta V over delta T. Again, I put the vector sign on the top so we can write with this formula, V final minus V initial over delta T, okay? Or I can rewrite this equation and I can write V final equal V initial plus A time delta T, okay? These are the two formula that we can, but the original formula is this one. Acceleration is delta V over delta T. I rewrite this equation, yes? When I rewrite, I can write V final equal V initial plus A time delta T. What is the V final? V final means final velocity. V initial means initial velocity, yes? What is the unit of the velocity? Meter per second or kilometer per hour, yes? Okay, meter per second. What is the unit of the acceleration? What is the unit of the acceleration? Meter per second per second. So how we can derive this unit? You see this formula? Delta V velocity, meter per second. Good? T is second. Okay? So what does it mean? It's meter per second, yes? Or we say meter per second squared. Again, when we are talking about the acceleration, I mean average acceleration. Okay? Example. Okay? Example. We have a person who is standing in the origin. Good. And what is its initial position? 0, yes? At the beginning is 0 meter per second. But he is not standing. When he is at the origin, he has a velocity. I say his velocity is 2 meter per second. Good. He moves. We don't know how far he goes, but we will be able to calculate later. Good. But after 2 seconds, his velocity changed to 10 meter per second. Good. Calculate the acceleration. What is the acceleration? And if you can, calculate the displacement as well, if you can. After 2 seconds, what is his position? Okay. The person was at the origin. His velocity when it was at the origin, okay, so it was 2 meter per second. But 2 seconds later, we don't know at where his velocity become 10 meter per second. How many seconds it takes to have the velocity to 10 meter per second? It takes 2 seconds. First, calculate the acceleration.
What was the time?
2 seconds. You know, we don't have the final position. Okay. you can calculate the final position as well. From the information that I provided, you can just work together, okay? So just discuss together, you have time. So acceleration is easy, yeah? Make sure to put this sign, positive or negative. It is important. Okay, it is important to put the sign for the acceleration. How about the final position? Okay, 2 minutes. Again, you can discuss together if you want. So if you don't want to use the formula, that's all right. Okay, try to analyze it conceptually first to understand what exactly happened. So we have a person whose velocity is 2 meters per second, and after 2 seconds, his velocity becomes 10 meters per second. Is slowing down or speeding up?
Speeding up.
Okay, the velocity is positive or negative?
Positive.
Why?
Forward.
Perfect, moving to the forward or right side of the coordinate system. Okay, when you calculate the acceleration becomes positive or negative?
Positive.
So one thing that you learn here, when we have a speeding up, the acceleration and velocity should have the same sign. If the velocity is positive, acceleration definitely needs to be positive. If the velocity is negative, acceleration, if you calculate the acceleration, is going to be negative. Good? So what is the acceleration here then? How many of you calculated? Okay, so let's calculate the acceleration here. Acceleration is, again, I can use the formula, good? Vf minus Vi, or change of velocity. How much the velocity has changed? It changed 8 meters per second. Good? Change of velocity. Positive or negative? Positive. Or I can use the formula. V final minus V initial, okay, divided by delta t. So what is the V final? Positive 10. Minus, what is the V initial? Positive 2 meters per second, yes? That's not right. Per second for now. Okay, divided by how many seconds it took? 2 seconds. Okay, so it's gonna be positive 8 divided by 2. So the acceleration is gonna be 4 meters per second square, or meters per second per second. Which part you didn't? By no, you cannot do this, okay? Because the definition, yeah, I know, okay, some students make me say, oh, that's all right, okay, so we need to know the formula is change of velocity over time. Change, how much velocity has changed? It changed 8 meters because it was 2, now it's 10. How much change? 8. How? But positive 8, yes? It is increased from 2 to 10, positive 8. And then these divided by how many seconds take for this person to move from this position to that position. 2 seconds. Positive 8 divided by 2. That's good. Okay, so again, that's a good question. So you need to divide the velocity change over time. Okay, so the acceleration is positive. So if I draw, if the velocity direction is right, acceleration direction is right. So I learned something. When we have a speeding up, when the object is speeding up, the velocity and acceleration should be in the same direction. If this person is moving backward, everything become negative, yes? The velocity was negative. If because this is a speeding up, the acceleration will be negative as well, okay, if you calculate. Position. What is the position? You remember I wrote down the second format of the velocity. It was xf equal xi plus v, but what is that v? Average v. Yes? Let me just write down the equation. X final equal x initial plus this v time delta t. What is this v? Average velocity, yes? How can I calculate? I have two velocity, yes? You remember the GPI of the class? How would you calculate the GPI of the class? Okay, add all GPI and divide it by the number of students. We have two velocity here. We add both velocity and divide it by perfect. What is the average velocity? So again, the velocity here, because we have two velocities, is going to be VI plus VF divided by 2. What is the VI? Again, with the sign. With sign. What is the velocity here? The initial velocity positive 2 plus. What is the final velocity? Positive 10 divided by 2 is going to be the average velocity. The velocity, again, let me just write average, is going to be 6 meter per second. Now I can place these average velocity, yes, here. Good. Let me just write the next one in the next page. Okay, so it was xf equal xi plus v time delta t. I find the average velocity. Average velocity is vi plus vf divided by 2. Positive 2 plus positive 10 divided by 2. So the average velocity is 6 meter per second, positive 6 meter per second. So again, I just trying to find the final position. What was the initial position? 0. Perfect. 0 plus. What is the average velocity? 6 meter per second. How many seconds it took to person to reach? 2. So what is the x final then? Positive 12 meter. See? So if I write down, if I draw, the initial position was 0 at t equals 0, and this person right now at t equals 2, the xf is 12 meters. Accelerating. So we don't have the same displacement, yes? Okay, 2 seconds later, it's going to be 12 meters. The person will be at 12 meters away from the coordinate system. We are done. Oh, okay. We almost done with this chapter, but whatever we will, and now you know how to calculate the velocity, calculate the acceleration, okay? So, and then you know what is the difference between the velocity, average velocity, and average speed, and you can calculate the position of the particle, okay? and if there is a constant velocity or we have a speeding or slowing down. So, and we will be using the same formula and same concept for all problems. Good. So, right now we can have, let's say, 13-minute break. Okay, so it is 10:22. We will start at 10:35. Okay. Okay, so we start with one question. So what is the unit of the velocity? And you can just go ahead and use your cell phone. Just select the right answer. Okay. So what is the unit of the velocity is meter per second, meter per second, or second. Okay, 10 responses. We have 14 people in the class, and I would appreciate if everyone participate.
Like Apple.
Class point. So you don't need to install the app, okay? So you just need to log, did you scan?
Put them in guns and then find them.
Okay, there you go. You can scan one more time. Okay.
Or just scanning a QR code.
Yeah. Scan the QR code or go to this website, classpoint.app. Okay. Good. Let's see. And we have, I'm closing the submission. The right answer is B, yes? The unit of the velocity is meter per second. The unit of the time is second. The unit of the position or displacement is meter, and the unit of the acceleration is meter per second, or meter per second squared. Good. So, thank you. Okay. So we will move to the next. So we just learned the motion with the constant acceleration, or motion with the acceleration. And we would like to provide an example. We already saw an example, okay? So we have a person whose velocity was 2 meters per second. After 2 seconds, his velocity become 10 meters per second. We were able to calculate his acceleration, and and we will be able to find what is the final position. One of the example of motion with the acceleration is free fall. So I would like you to just explain. So the question is, what is the free fall motion? Is it speeding up motion or a slowing down motion? And what is the direction of the acceleration? Write down any information that you have. So what is the free fall motion? And does free fall motion has acceleration? If it does have acceleration, you don't need to know about the magnitude, okay? So, and what is its direction? Write down any information that you can discuss and just work together. fall freely? You can put your comment about the acceleration, about the motion, the- what kind of motion we have, speeding up or slowing down. Speeding up, yes, there is acceleration. So if there is acceleration, what is the direction of the acceleration? Positive acceleration, what the positive acceleration means? Going down, speed up, yes, acceleration, going down. So we have more speeding up, okay, so acceleration is positive, free fall is falling down. Negative acceleration. So negative acceleration, because you say negative acceleration, so it means that if you are choosing a coordinate system, the acceleration is in the opposite direction of the coordinate system, yes? Okay. But if you are telling that positive acceleration, if you are choosing your coordinate system, your acceleration is going to be in the direction of the coordinate system, positive direction of the coordinate system. So I ask, okay, so you always say the free fall is just dropping object. Do we have? Let's say we have fall, good, and then what exactly happened? You can keep writing whatever you want. Okay, you can probably when I'm explaining, you change your mind. You can just add more stuff. So now, what is the velocity of this ball right now? Okay, so when I drop it, okay, so it's gain velocity. It's speeding up or slowing down? Speeding up. You remember I said when we have a speeding up, the velocity and acceleration should be in the same direction, or they have a same sign or same direction. Good. So the velocity direction is downward or upward? Downward. What is the acceleration direction then? Downward. Yes, because we have a speeding up. Good. So free fall. This is the example of free fall. I drop the ball. Good. The velocity downward. The acceleration is downward as well. This is a speeding up. Okay. How about this motion? You know, I threw the ball into the air, okay, and it goes and then come back to the ground. How many motion we have? Positive, the ball stop, okay, and then move back. So we need to analyze both motions separately. This is another example of the free fall. Yes, okay. So this one, the ball you drop, okay, the initial velocity is 0. This ball at the beginning, it does have a velocity. It goes up and then it stops and then move down backward. I would like to analyze these motions separately. Okay, when it's moving up and it stops, and then when it's moving down. We already analyzed when it's moving down. Velocity and acceleration in the same direction. But when I'm throwing it up, okay, until here, what exactly happened? Is speeding up or slowing down? Slowing down. Good. When I'm moving up, okay, so it goes up and the velocity gets smaller, smaller. It's becomes 0 and then move back. Yes. Velocity is positive. How about the acceleration? How about the acceleration? So you know, I throw the ball, okay, from here to here. What is the direction of the acceleration? How many positive? Raise your hand. How many positive acceleration? Raise your hand. When it's moving upward. 1, 2. That's all right. If you make a mistake, that's completely all right. Okay. 1, 2, 3, 4. How many of you say that the acceleration is still downward, negative? Which one is the right answer? So watch, see here. When it's moving up, the velocity is slowing down, yes? It's slowing down. The velocity is upward, good. When we have a slowing down, the velocity and acceleration should be in the opposite direction, or they should have this opposite sign. If the velocity upward, acceleration is down.
Is it kind of like what we were doing with the starting points where when they went backwards, did it become?
Yes. Okay, so, but here, okay, so the velocity is positive, but because the velocity gets smaller and smaller, we have a slowing down. The velocity upward, but when we have a slowing down, the acceleration should be opposite. So, you drop, the acceleration is downward. Good? You throw ball, the acceleration, it doesn't matter. When it's thrown up, the acceleration is going to be downward as well. Because this one is slowing down, this one is speeding up. Good?
Gravity is a constant force, right? The force exerted on the ball by your hand is a one-time force.
Yes, this is a one-time argument. That's why I'm just trying. Okay, we just analyze these after releasing from my hand. Okay, so yes, there is a force being exerted.
So the instantaneous force will be reduced until the constant force is greater, in which case it peaks and falls, right?
Yes. Okay. So again, I am analyzing. Okay, these when is it start releasing from my hand? Okay, I assume that there is no force being exerted. Okay, but definitely there is a force being exerted. So we will be discuss about force looking in the next unit next week. Okay, we have a force. Okay, external force. Good. Okay, so thank you. We have the acceleration. So the positive acceleration is not right. Okay, so the acceleration is downward. We call it negative acceleration. Okay, so we use the same coordinate system. You remember I was using these coordinate systems for linear motion. I do the same thing but y-axis. This was x-axis. Now this is a y-axis. 0, positive, and negative. Good. Okay. Thank you. Let me just open page. Oh, no, not this one. Okay, so we have a coordinate system, 0, positive, negative. Okay, you are on the ground. Let's say this is here is a ground, yes, ground, and you are just dropping a ball. Okay, it's going up. Good. When it's going up, okay, it's go here and then stop. It does have a velocity at the beginning. It does have velocity, initial velocity, and its velocity is positive, upward, and it goes here, and then its velocity becomes 0. Good? But when it's moving back, we are expecting the ball move backward. Okay? So the velocity here, I just draw the second motion here. So the velocity here is positive, but it's going down. Okay, so it's going down and then reach to the same person. Good. So we have a velocity, but the velocity here is positive. The velocity here is negative. Good. So this is going to be the example of free fall. You can throw the ball upward. Okay. So in the first one, what exactly happening to the velocity? The velocity is getting smaller until it becomes 0. We have a slowing down, a slowing down, Okay, is moving upward and then moving down. When it's slowing down, the velocity, because the velocity was positive, the acceleration should be negative. Good. So the acceleration is always, this is going to be the acceleration. Okay. I'm not talking about the magnitude of the acceleration yet. So I'm just trying to see in this motion, there is acceleration or not. If there is acceleration, what would be the acceleration direction? So in the second one, the ball is here and then speeding up. Good, when it's reaching to ground. So speeding up. So the velocity is positive. So acceleration, sorry, the velocity is negative. My bad. Because it's downward, yes? The velocity is negative. So the acceleration should be negative. So the acceleration is still downward. It doesn't matter that you're throwing the ball or you're dropping the ball. The acceleration of a free fall motion is always downward, is negative. And this negative shows the direction. And the value, you may say, okay, what is the value of the constant acceleration or gravitation? We call this gravitational acceleration. The value of the gravitational acceleration is negative g, or negative 9.8 meter per second square. Good? So we just learned about a motion which has a changing velocity, and this motion is a free fall motion. You can drop the ball, you can throw the ball into the air. The acceleration is always negative, acceleration is always downward acceleration, and its value is 9.8 meter per second squared. Okay, and the direction is downward or negative 9.8 meter per second squared. Good. Okay. Because I already explained, okay, so the old formula, and we have a new motion. We will start with the problem. I don't want to solve the problem because we already solved the problem similar to this. Okay, I will let you just do whatever you can do, whatever you have learned, apply whatever you have learned in the next problem. And then we are done with today. Okay, we just need to analyze the graph, but we will analyze the graph when you run the first experiment, okay, which is Thursday. Hopefully I will be here Thursday, just letting you know that I may not be able to come Thursday, but I will ask other instructor to just be my sub, but it is not finalized yet. Okay, 50-50. I may come Thursday. If I come, okay, we will run this experiment together. If I don't come, I will ask my colleague to come and run the first experiment, which is the graph matching, and it is a very funny experiment, okay? So, and then when we do the graph matching stuff, when you play it with the motion detector, then I will explain the graph of position versus time, velocity versus time, acceleration first. I would like you to experience it first, and then I will lecture it. Good? So, we have, right now it's 11, 5 minutes to 11. Next problem, what I want you to do, okay. It is a question, and I would like you to just work in a team and then submit your own answer. You have almost 10 minutes to work on this problem. This problem. Okay? So what is the problem? We drop a ball from 20 meters above the ground. Let's say it is a ground, and there is a ball which is 20 meters above the ground. So what is the velocity of the ball 3 seconds later? So it means that the ball, what is the velocity of the ball? Nothing. 3 seconds later, what would be the velocity of ball? And then how long does it take the ball reach to the ground? Good. We have a ball 20 meters above the ground. How long does it take the ball hit the ground or reach to the ground? Good. So work in a group, you have all formula that you need. Again, here acceleration is going to be negative 9.8 meter per second squared. First thing first, draw the situation. Draw the situation. Draw the coordinate system and then analyze the motion. Good? Okay. Let's go. When you complete that, okay, you can submit your answer here. Yes. It is in page. It is, yeah, free fall distance example. No, no, it is not here. I just.
Okay.
Because I will.
20 meters.
Because we have it. I will save this and put the PowerPoint. So you will have two copies. Yeah, please work together. Everyone discuss, analyze this. Draw the situation and let's say where is the ball right now? Okay, and 3 seconds later, what would be the velocity?
Oh.
Well, what? It's just algebra, so take the equation to find the acceleration. So,
Okay, so sorry, can I ask you to change one thing? Okay, so change the position to 80 meter.
Okay, I was
Okay.
wondering.
Okay, good. Change the position to 80 meter. Just a little change, okay? Position 80 meter above the ground. Good. But it doesn't mean that the last one was wrong, okay? So the last one does need a little more analysis, okay? So I will explain why. So just think about this first. Okay, yes, just submit. Don't worry about being on because you will not be evaluated by this.
Okay, good.
Okay, so you just need to just show that you are working. So I'll just give you 30 seconds, okay, to submit, and then because we don't have enough time.
Zero.
Oh, they heard.
Good. We have one more. We need one more. No, that's last. We have time.
Oh, you're sure?
Okay, next time we will, because we have just 10 minutes, okay? We may not be able to evaluate yours, good? But it is good that you show that you are actively engaging in the class. Okay, so, but next time we will open each one and I give you instant feedback about your calculation because we have just 8 minutes. This time I may not be able, but I will probably open one. So, did you submit? Okay. Okay, and this next 8 minutes, it is very important, very important. Please listen carefully, and I am recording this session. Okay, you can go and watch it this later as well. For any problem, you need to just do the same analysis that I do here. Okay? Good? Did you submit it? Okay, perfect. Good, perfect. So close submission. Okay, so thank you for participating. So let me just randomly open one. Let's say this. Okay, we need to make it a little bigger. Okay, so I cannot read anything. Okay, this one. It does show that you have calculated the first part. Yes, V final equal V initial plus acceleration time delta t. V initial is 0, and we have acceleration negative 9.8 or negative 10 meter per second squared. Time 3 is going to be negative 30 meter per second. The velocity 3 seconds later. So, good. Okay. Let me just show you how we can analyze this problem. Let me just open a page. Okay. So what was the question? We have a ball. It is 80 meters above the ground. I just draw the ground. You always need to draw the situation. And there is a ball is above the ground. Okay. So how many meters? 80 meters. Okay. So, and it's telling what is the velocity 3 seconds later. Oh, why? Oh, okay, let's say what is the velocity 3 seconds later? Okay, and how long does it take the ball hit the ground? Yes? Okay. So when I am solving this problem, I need a coordinate system. So coordinate system, it does show the position of the particle. Good. You remember when I was moving to the right and left? Okay, I use the coordinate system. So I just draw the coordinate system. And you can place the coordinate system wherever you want. So you can place the origin of the coordinate system on the ground, or you can place the origin of the coordinate system where the ball is. So I just say this is origin, yes. This is positive and this is negative. Good. So what is the initial position of the particle then? Right now, 0. Perfect. Now, when the particle hit the ground, what is the final position? Okay. Negative 80. Okay. Good. But this final position is the time when it's hitting the ground. Yes. This final position is for this t. Okay. Good. So, and I just solved the first part. The first part is telling what is the velocity. Okay, final, it means that 3 seconds, right? Equal to initial velocity, acceleration multiplied by delta t. Okay? So V final when it's 3 seconds is, what is the initial velocity here? Because you drop the ball. It is 0. Good? 0 plus acceleration. Gravitational acceleration is negative g. I round it to the whole number. It's going to be negative 10 meter per second squared. Good. So I plug this negative 10 here. How many seconds later? 3 seconds later. Okay. So the V final after 3 seconds is going to be what? Negative 30 meter per second. 3 seconds, negative 30. 4 seconds later, negative 40. 0, yes? 1 second later, negative 10. 2 seconds later, negative 20. 3 seconds, negative 30. 4 seconds, negative 40. 5, 10, okay. So you can do the same thing. Every second, the velocity increasing 10 meter per second. But downward. That's why it's negative. Okay? So, again, 1 second later, let's say 1 second later, what is the velocity? Negative 10. Good. 2 seconds later, the velocity is going to be negative 20 meter per second. 3 seconds later, the velocity is negative 30 meter per second. Good. Okay, next part. So how long does it take? So, oh, so the ball is here. This is a coordinate system. Okay. So the ball is here and this is a ground. Okay. So 80 meter above the ground. So X initial is 0, X final is negative 80 meter per second. Okay. So, and what was the formula? And we have the V, and we don't know what is going to be the V final when it's hitting the ground. Yes, because we don't know how many seconds it's going to take the ball hit the ground. So, but what we can do, we have a formula. Okay, you remember XF equal XI plus V time T or delta T. Good. And you remember there was one formula, V final equal V initial plus A time delta T, yes? Okay. And you remember that this velocity was average velocity, yes? What was the average velocity formula? V final plus V initial divided by 2, yes? What is the V final? I just call it V. I don't know. But I already know V initial is 0. Perfect. So I can calculate here. V final, I don't know. That's all right. Plus 0, good, divided by 2. So V is going to be, so let me just put this average. This is the average V. Good. It's going to be V over 2. Okay. I just put the sign on the top, just differentiate between the other V. Okay. So I can place these, yes, here. So when I place this here, X final equal. What was the X initial? 0. Plus, what is the V average? V over 2 times T, yes? Good. So from here, I can calculate the T. See? What is the V final? Again, I just write here. V. What is the V initial? 0. Yes. What is the acceleration? Just acceleration time t. Yes. So we have V equal a t. Good. So I'm driving the equation. Okay. So because you already know that the equation is 1 over 2 at squared, I'm just showing you how we drive the equation. So I just plug this velocity here. So X final is going to be V over 2, acceleration is sorry, instead of V, I just plug AT, yes, time 1 over 2t, yes, is going to be 1 over 2 AT squared. The distance traveled, yes, the displacement is going to be 1 over 2 AT squared. This is the formula that you need to memorize. I just showed you how I derived it, yes, but you need to memorize. Okay, now I have the x final, yes. What is the x final? Negative 80. So I put negative 80 here. What is the x final? Let me just write it down. Okay, let me just open a new page. Okay, so xf equal 1 over 2 AT squared. In the slide, you see it is d1 over 2 AT squared. Okay, it doesn't matter. So xf is what? Negative 80 plus 1 over 2. What is the acceleration? Negative 10 meter per second. Negative 10 equal t squared. Good. So here, negative and negative cancel each other, yes? What we will have, we just have 80 equal 1 over 2t squared. From here, just mathematics, okay? So what we do here, I just multiply both sides by 2, both sides by 2, yes? Okay? So these 2 and 2 cancel each other, so we will have 160 equal t squared. Good?
It's supposed to be an 8, not an 80. You cancel the negative 10.
Oh, yes, yes, yes. My bad, my bad, my bad. So, yes, yes. Good. So right now, what we need to do, because we are supposed to find the time, but this is t squared. What we do, we just square the both sides. Square root the both sides. Okay, let me just use different color. I do a square root of the both sides. So t is going to be a square root of 16 is 4. So it takes 4 seconds, okay, the ball hit the ground. Yeah. So we learned this formula. If I want to write the complete form of this formula, it is this: xf equal xi plus vit plus 1 over 2 at squared. This is the complete version of this formula. Sometimes you don't drop, okay? So you just move. It does have initial velocity. For this example, it does have initial velocity. Good, okay? So you need to know VIT plus 1 over 2 delta t squared. So I have recorded this, okay? I will try to put this recorded session, okay, in your D12, yes? And then also I will upload this PowerPoint, the updated PowerPoint in your D12. Okay? Okay, have a great day. Sorry for taking 5 minutes of your time. Have a good day.
So,